Well, boys and girls, welcome and thanks for joining me once again for a new series, I'm thinking perhaps, of videos that I'm putting together, and I think I shall call them folks who have more subs than I do. Here's an example. Today we're going to deal with a gentleman who has more subs than I do, and he is a gentleman by the name of Dell. And Dell hails from sunny Glasgow, up there on the west coast of Scotland. You may have to tune your ear slightly because he does speak Glaswegian English. In other words, he has a very, very thick Glaswegian accent. I may well see if I can organize some subtitles to make it just that little bit easier for those whose ears are not tuned to the dulcet tones of Glaswegian English. What I can say about Dell up front, I won't spoil it for you. You can work out the rest of it for yourself. But the one thing I will say about Dell up front is this. He is perhaps even more adept than I am at the double banger insult towards people. He has some real doozies. I think I'm going to steal some of them. Thanks very much for that. If for nothing else, including some pretty good laughs when I was watching through this one. Dell, good work, son. Let's have a look at Dell's video, shall we? And I'll do my usual point-wise response. Shall we? What fun. Let's do that.
Obviously, Tinterwebs is not working right. Typical, just as I go on, the sun decides to make an appearance. Really warm, but no sun. How are we? He's alright. It is hot today, yes. The sun's just starting to make an appearance, so this isn't going to be that long today anyway. Just wanted to have a wee demonstration and a wee chat about these things. So I'm sure many are aware. Obviously, I've spoken about this so many times. When we're talking about visible optics, we have to understand what it is we're utilising in regards to the eyes, and ask some questions about those apparatus and how we perceive the world. So, again, just to make some quick points before we go any further, I'm going to show you one of these curve calculator things here. I was going to draw it, but I've got stuff written on there that I need to remember, so let me just share screen. So, obviously, many people have seen this continually. I've got a curved surface here, and usually they'll show you a representation of you standing perpendicular to the centre of gravity, that stuffsies. So
the gravity, that stuffsies,
But, they're always depicting this, and if you look at this, remember, you're always at the top of the supposed sphere, so really that arrow should be here.
Why, Dell? Only if gravity worked directly down with respect to the top of that sphere as it is shown on that piece of paper from every angle around the 360s of the globe, which it doesn't, Dell, does it? No, son. It pulls towards the centre of the Earth, irrespective of where you are on the surface of the Earth. So the actual angle of pull directly straight down towards the centre of the Earth changes as you move across the surface of the planet. So there's no reason why you would need to put someone at the top. You can put someone where they've shown there at H0, perfectly valid. They've even got the angle of the person standing directly upright, perpendicular to the line of the pull of gravity at that point on the Earth. It's quite clear what we're looking at here. And that person is looking very slightly down for their eyes to meet the exact level of the horizon, which is shown there with the nice big arrow so that even people who aren't too clever can see exactly where that is and why that occurs. It's because of the occlusion of the surface of the Earth beyond that point by the bulge, if you like, of the Earth that is in front of that point. That's why we have a horizon. That's why we have a limit to what we can see across, for example, perfectly curved water. Goodness, I nearly caught myself out there, didn't I? It's not flat, it's curved, of course. What I mean is not with big waves and things on it. It's straightforward. There's nothing mystical or magical or what Del might call that stuffsies, gravity, the stuffsies. No, it's all pretty straightforward. It looks like you could do some pretty basic trigonometry there and work out exactly what the angles are and exactly how far the horizon should theoretically be if there was no distortion of the light rays by the gravity between yourself, by the atmosphere between yourself and the point that is the horizon effectively on that day. And we know how far that is. We'll get to that a bit later on though. So anyway, let's see where Del's going with this, shall we?
And if you look at this point here, you'd be looking downwards.
Yes, you would. As it turns out, Del, it's about 0.02 degrees for your eyes to meet the horizon, which is an angle which is so fine that you are unable to detect it. Your brain can't determine the difference between perpendicular to or orthogonal to the line of the pull of gravity and 0.02 degrees below that. It simply doesn't have that level of accuracy kinesthetically or in any other way. So yes, you are looking down, absolutely, but almost not, if you get what I mean.
Okay, looking down to your horizon and looking down to see things apparently being obscured by a bulge that rises up in front of you.
No, it doesn't really rise up in front of you. That's not what's going on here, is it? Because if you look at the angle which is perpendicular to the pull of gravity here at H0, where your little arrow is there, Del, you'll see that that's the line there that's 90 degrees from the line of gravity. So actually this bulge is not bulging up in front of you. It begins perpendicular and then it drops away. Pretty straightforward, I would have thought, but only if you can understand that gravity pulls towards the center of the Earth. The angle of the surface of the Earth changes as a function of where it is around that center of gravity. That's why the Earth is a sphere. Pretty straightforward. No, it doesn't rise up in front of you. It curves away from you, a downwards motion. Fine.
When in reality, that's not what happens.
It doesn't happen. It doesn't bulge up in front of you as covered.
Now, the geometry of a sphere shows you that these people in their observations are obviously wrong and disingenuous.
Why, though? There's nothing wrong or disingenuous about this diagram at all.
Maybe they're just confused about
I think we know who's confused, Del.
the things going on. Because as you stand here at the top of a sphere...
But why would you be necessarily standing at that point? You could be standing exactly where the person is standing at H0, and then you could actually draw it the same way. You could draw the person there if you want. You could make that your reference point. It doesn't make any difference to what it is that you actually see. It just moves the whole thing around. The same effect occurs wherever your reference point is, wherever you start from, wherever you are stood, Del, because it's a sphere. Goodness. This isn't difficult if you actually managed to get as far as your GCSEs. You'd understand this, surely.
Okay, the floor curves away from you 360. Okay?
That's right. Anywhere you are stood on the globe Earth, the floor, as you call it, the level of the ground, does curve away from you in a downwards away from you type styly. Good. I think we're getting somewhere.
Every direction.
Yeah, right. So look at if you impose yourself as being where that horizon arrow is on this example and place yourself at the top of the sphere so that you can understand it, Del, that's what you're seeing, isn't it? Everywhere drops away from you. There's no bulge in front of you. Everything's flat and then away. And a downwards styling. Simple. Same thing over that way where you've got the H0 arrow. Just rotate this diagram around so that H0 comes to the top, Del, and you'll see the exact same thing there, won't you? Because, goodness me, this isn't that hard.
An exponential
Del has more subs than I do.
Curve dropping away. Now, when we actually look at that, you look and you think to yourself, well, in reality, if I was on a sphere, I would actually be able to see a lot further.
Why, Del? Give us some reasoning.
Than, what they're stating and what they're arguing about.
Okay, so trigonometry is wrong, is it, Del? Triangles are not a real thing. The internal angles of a triangle don't add up to 180. And from that, we can't determine the length of all three sides of a triangle using trigonometry. Goodness.
And also, as I elevated upwards, I would be looking increasingly more downwards.
And that's exactly what you do see, Del. As you elevate yourself upwards, you can see increasingly further because you are able to look further down the curve away from you, and the point of the horizon effectively moves further away from you. There are many, many fine videos on YouTube if you'd actually like to have a look at some of them, Del, that explain this to you using aeroplanes flying at various altitudes as examples, or using people climbing up hills and using apparatus to show that the line of the horizon drops away. It's quite simple. It's not difficult to understand, even if you do have 20,000 subs, Del. Goodness.
So for talking's sake, they're talking about if you're standing here and you're looking at an object here, it's obscured by some hump somehow that rises up in front of you.
No, Del, it doesn't rise up in front of you. We've covered this.
Well, that they'll say is the curve of the Earth.
That's because it is the curve of the Earth. That's why they say it's the curve of the Earth that causes this phenomena, Del. It's well established.
Okay, so it must be a fixed reference point, which means as you elevate up, your angle of looking down would...
Why must it be a fixed reference point, Del? And if you elevate up, you'll be looking further because the horizon will move further away as described. That's trigonometry, it's triangles. I think that's the problem here. I think you've never done any even remotely high school mathematics, have you, Del? Okay.
Increase ever more so, and you would be seeing further and further down the sloping away.
Yes, Del. Absolutely.
Earth. Okay? So let me just come back before I go any further. So when you get 2 points here, what the globe is always trying to propose is that something rises up in front.
No, Del, because two people standing on the globe aren't perpendicular. They're splayed. So each one of them is seeing flat in front of them and curving away as distance increases. It's quite simple, Del. Goodness me. 20,000 subs Del's got. Congratulations on that, Del. That's good work, son.
Of both of you, like a hump in between you.
I wonder if the IQs of all those 20,000 subs added up together would be more than 2 or 3 of mine.
Now, it doesn't take a genius to work out that geometry is something seriously wrong with that.
Yeah, I think it doesn't take a genius to work out what it is that has something seriously wrong with it, Del, and it's not a something that has something seriously wrong with it. It's a someone that clearly has something seriously wrong with it. Yeah, let's move on.
Because if you're on a sphere and you get 2 people, you should have something rising up in front.
No, they don't have anything rising up in front of them. We've covered this so many times. Saying the same stupid thing over and over again in a video doesn't make it any less stupid every time you say it. It only makes it even more funny. So keep saying it, Del.
Okay. That would mean that each person was standing inside a dimple.
Each person standing inside a dimple. No, Del. No, goodness. Good.
Okay, so that when they turn around, they see another hump like that.
No, they don't see another hump, Del. No. Nobody's suggesting you're going to see humps every direction you look. What we're suggesting is if you're stood on an otherwise nominally level area of the Earth, let's say a huge salt lake, and you look around 360 degrees, you turn around slowly and look around 360 degrees, if the salt lake is large enough to allow this, you will see a horizon all the way around you, which will appear to be a flat, level, and horizontal line of occlusion of your vision beyond that point. Because you are stood at the top of a pumple rather than a dumple, Del. Okay?
Us, and it's just a series of humps.
No, oh, fuck. Woo. Del. Thanks for the laughs, Del. Should we actually say something worthwhile now? Or are you just going to talk about the same stupid thing again and again and again and get it wrong repeatedly again and again all day?
In front of them. That's not reality.
That's right, Del. It's not reality, and nobody is suggesting it is reality except you, because it's a straw man, which is... Well, it would be a straw man if you actually had the intelligence to realise how stupid what you're saying is, and you're saying it anyway to prey upon people who are even stupider than you are. But I don't think that's what you're doing, because I think you might struggle, Del, to find someone who is stupider than you are. I really do.
So asking questions, and what I done was I set up a wee display.
Oh, this will be good.
Of a curved surface.
Good.
And again, remember, if they come back into this and they start talking about scale, by mentioning the word scale, it actually gets worse.
So if anybody mentions the word scale, it gets worse. What gets worse, Del? Exactly.
The globe proponent. Because if you understand the circumference of the supposed globular Earth,
which we do,
Earth at 24,000 miles, and the size of you in comparison to that.
Yep.
Okay, the curve would be ever so slight.
It is. That's why you can see quite a long distance, Del.
Very, very slight.
Yes, absolutely. That's why the angle down to the horizon is only 0.02 degrees or so. And you can see quite a distance.
Right, and nothing would be obscured for hundreds and hundreds of miles.
No, in fact, it's around about 3 miles or 5 kilometers if you do the actual mathematics of the actual trigonometry, Del. Again, assuming that there is no distortion of the light rays by the atmosphere and other artifacts of heat and that kind of stuff, distortion between you and the horizon, and you're a 6 foot tall individual, you can do the math, you can do the trigonometry. The range of vision on the Earth, which has the diameter that it does in fact have, Del, whether you like it or not, is about 3 miles or 5 kilometers, not hundreds and hundreds. Okay, pretty straightforward. Anyone can do the math if they want to. If you're unable to do it, as I'm sure that patently you can't, Del, you can actually go and look it up online if you could be bothered to actually do any fucking research at any point in your life to find out why it is that what you're saying is so fundamentally, utterly stupid. Okay, I don't understand the triangle, says Del. I don't understand math, says Del. I don't understand gravity, says Del. So I'm just going to make shit up. Hundreds of miles, says Del. Okay, good. No, Del. 3 miles, give or take. 5 kilometers or so. Straightforward. Simple. Angles, length of sides of a triangle, not a difficult proposition to work out.
I'm about to show you.
Yeah, I think you better show us how it's going to be hundreds and hundreds of miles, Del, because those of us that understand geometry, trigonometry, mathematics, logic, and gravity, we understand how this works. So please enlighten us as to how this works, because we've clearly got this badly wrong.
So let me just get this up here. Hopefully that's showing that. Yep. So these were wee sequences. So the sequence is kind of jotted about, but you'll see exactly what I've set up here.
Not so far, Del. I think you better explain it.
Just as an example.
Good Goodness me, did anybody see the vehicles in the earlier shot that was looking straight? Wow, it's almost as if that supports the curvature argument a bit.
Now again, what you have to remember is that 1 degree of the sphere is roughly 70 miles. Okay, now the majority of these observations that people are showing and arguing about are not even half of that distance. Okay, you're talking, less than half a degree.
Yeah, okay, so if you impose the scale of the curvature of the Earth on that curved piece of board there, Del, and then you worked out the actual scale of those wee toys there, you would find that they're all enormous. Hundreds and hundreds and hundreds of meters tall. Possibly thousands by the look of it, Del. So your model is invalid. It does not match the reality of the curvature of the Earth, and as such, I'm really not sure what you're trying to show us here, except your stunning Dunning-Kruger.
Okay. Already, from the point of the camera to this first, you're about 5 degrees.
Yeah, but how big is that wee toy? And your huge mitt with respect to that model, if everything is to scale, Del. Enormous. Massive. That's people would think that's Armageddon if they saw that, wouldn't they? Look at that vehicle disappearing from the bottom up already. The one behind the yellow, whatever bitty that Del's poking around with his big mitt of God there. It's almost as if that's what we actually see when we look at boats, for example, going over the horizon, disappearing from the bottom up. So that the hull disappears progressively from the bottom up, and then the mast disappears progressively until we can't see anything at all. Goodness, good work, Del. You've supported the round Earth there, the globe Earth. Good.
And again, note that nothing is rising up into the centre of the field of view.
Yeah, we've covered this with Del. That's not what you'd expect to see, because wherever you're stood on the surface of the Earth, you are standing perpendicular, orthogonally to the line of pull of the gravity, which is directly towards the center of the Earth. So people who are separated, for example, by 45 degrees on the globe will be standing at an angle which, relative to each other, is separated also by 45 degrees, son. Good. So therefore nothing rises up in front of you. It appears flat in front of you and then curves away from you, as we are seeing right here in this example. Perspective, of course, makes it look like the thing is up above our eyes. It's not. Of course, that's a perspective artifact. Goodness me, none of this is difficult yet, Del.
The camera's leveled, it's on a level table looking straight ahead, and the curve drops exponentially away.
It drops away, not exponentially, but it drops away, yes.
From the point of the observer. It does not rise up into the centre of the field of view. Yeah, nobody says it does, Del, except you, because you don't understand anything at all. It's stunning. I did have to watch a number of your videos before I made this one to make sure that you weren't taking the pash. You're serious, Del, and that's what's worrying here. You really think that you have a point here. Wow. 20,000 subs is Del. Good work, Del. Oh, the hand of God. Oh, no, it's all right. It's just Del. Del giveth and Del taketh away. See that? Goodness. Oh, you fucking retard.
Yes.
So, we still have one object left here. I was taken straight up. Note.
Oh, look, now you can see it. Because... Oh, God, do the trigonometry. Goodness, Del. Thank you for, once again, conceptually proving the globe Earth for us. Good work.
Don't focus on the object.
No, don't look at that. That you can now see, as you would expect. I'm going to divert your attention in some other way. How are you going to do that, Del?
Remember the centre of field of view is here. Nothing here is rising up with us as we rise
Yeah, we've covered that.
up. That the drop continues to go down.
Yes, as would be expected on a globe.
And now I would have to tilt to look down.
Yeah, as you do when you're looking straight across at the horizon, wherever you're stood on the Earth, Del. Slightly down, 0.02 degrees if you're a 6 foot tall individual, give or take. If you're in an aeroplane at 30,000 feet, obviously you're looking at significantly more of an angle downwards. What's your point? It's what we'd expect. As such, the circle inscribed by your line of sight around the planet would be enlarged by that. You can do some math to work out exactly what that distance should be theoretically, and then we can see if we can map that out and see if it matches that observation. And fuck me, Del, it does. Goodness. Goodness, look at that ball disappearing from the bottom up progressively, as we'd expect to see on a globe. And as we do see when a ship sails away from us across the line of the horizon, Del.
Neil, can you just give me and hold that there for me? Aye, just hold it there. And just let it touch it. So, right, keep going away, Neil, and let it go down. Right, so if you stop there, same again as we elevate up. And this is the absurdity of a globe proponent talking about a sunrise and how it's going down beyond the curvature of the Earth.
This will be good.
Now again, in reality, as you elevated up, you would be able to look down at the sun.
Yes, and that's what we observe, indeed. If you are on an aeroplane flying towards the sunrise as viewed from a fixed point on the Earth below where the plane is at any given instant, the people on the plane will see the sun before the people at ground level will see it. That's what we expect. That's what we see. Goodness, it's almost like this thing is a bit of a slam dunk, isn't it, Del? I find it difficult to understand what point it is you're trying to make here, but please do go on.
Which nobody ever does. Nobody looks down on the sun.
Goodness me. We're talking about relativity in terms of what's down with respect to what and all that kind of stuff. The sun is a burning ball of gas, 1 million miles in diameter, distant from the Earth by a distance roughly equivalent to 93 million miles. The line of sight to the sun from any given point on the Earth that happens to be at that time experiencing the sunrise situation will be pretty much, if you're a 6 foot tall individual and there's nothing in between you and where the sun's coming up, so let's say you're looking across the water to the sunrise, roughly 0.02 degrees down with respect to the line that is orthogonal to the pull of gravity on the point of the Earth where you're stood. Yes, Del, they do look down at the sun. Okay, let's move on. Ever. That makes your wrong statement much more powerful, Del. No, it's still wrong.
No, you stay there, Neil.
Goodness me, you really need to train your beautiful assistant to be a bit more knowing about what it is that you're thinking and getting them to try and achieve their Del before you start, I think. Perhaps, if you're going to do that, you should also think about what you're going to say before you say it. Maybe submit some of your commentary to some kind of filter. Maybe talk to someone with an IQ that's got double figures at least in it. to see whether what you're saying is remotely sensible or not before you say it, Del. That would be a good idea. But anyway, let's see where you're going, shall we?
As we elevate up, what's happening?
Well, obviously, what's happening is exactly what you'd expect to see and what we, in fact, do see.
The sun remains in the lower portion, so does the earth, and we would have to tilt downward.
As you do with the line of sight to keep the sun in the centre of your field of view, if that's what you're doing. What's your point?
In order to look at it. Let's just see that again. Bring it back up towards us, Neil.
Good work, Neil. That's class.
Keep coming. Keep coming.
Oh, no. Gee,
Right. And if we stop there, so as we can see from here, and we see the distance, if we use that as some sort of scale representation, you can see that from here to here, we're talking, more than 5. Maybe I'll be generous and say it's only 5 degrees, and that's being really generous. It's much, much more than that. But we're talking, more than that, probably 10 degrees. Well, as I was saying, 10 degrees, you're talking about 700 miles. Keep bringing it back towards us. In fact, I'm going to use the other prop. So here we're at about, a generous, I'll say, 3 degrees. Move the bobby. Nothing has been obscured. Nothing.
But not so, actually. Not so at all. If you make that vehicle the correct scale, you will see that it's probably almost completely occluded by now. And actually, if you do zoom in very, very close on that image there, Del, you'll see that the bottom part of the arcs of the wheels are already actually occluded there. We just need to look closely enough to actually see that, which would require you to use some kind of magnification device to achieve that.
And the distance from here to here is...
Not to scale of anything, is it? It's just a piece of curved board that you've clamped to a bench and allowed to curve away. Under what force, by the way, is causing that board to bend, Del? Why is that board bending away from you when you've clamped it at one end to the bench and left the other end free to...
Well over 10 degrees. Further still. I can't see that. I'm going to have to wait until...
So look at the wheels. They're starting to disappear from the bottom up, as we would expect, because they have disappeared beyond the line of the horizon from this example. And more so now. Now it's much more obvious.
And again, just to show you, again, we've got the centre of frame, and as it goes away, it curves downward.
Correct. It's exactly what we'd expect. Yes.
It's away from us.
Yes.
It doesn't keep going straight out in front of us.
Right. So that proves absolutely, without question, the globe Earth, doesn't it, Del? Because that matches what we view in the real world when we actually go and observe things in the real world. The actual objective reality that we live in over here, Del. I don't know where you live in your mind. Well, I know where you live physically. It's Glasgow, but which, by the way, was very, very close to the exact opposite side of the Earth, the globe Earth, to where I live.
Down the way, this is the geometry of a sphere dictates that you're at the top of the ball and that it must drop away from you in every direction.
Which it does, you cockwomble.
Hang on a wee second here. Right. We elevate straight up from that point, and it remains fixed, and it continues to lower as we elevate.
Yes, and that's what we see.
And then we have to tilt. Now we'll be looking down the slope of the Earth.
Yes. This guy's good, isn't he? Perhaps he does deserve 20,000 subs after all, because he actually seems to be clearly and repeatedly showing us exactly what we would expect to see on a globe Earth, which matches exactly what we do, in fact, see. The problem here, Del, though, is that you're presenting this information as some kind of proof that the sphere does not exist. We're all a bit lost as to how your logic's working in this respect. Anyway, we're about halfway through. Let's see where he goes.
Can you remove that first car, will you?
All right.
And just slide that one further away. We elevate further up from here. I'm sure it now comes out of view. And now we have to tilt to look down at it.
Yes.
Right. So just to show the curve.
Yeah, again, what's causing that board to curve, Del? Is it some kind of magical sorcery? Why isn't that board just continually... It's almost as if there's some force on the actual Earth at the scale that we're actually working here, pulling straight down effectively across every square inch of the floor area across which that board is extending in a perpendicular line straight down towards the center of the Earth to all intents and purposes, because it's a long way to the center of the Earth from where you are, and the angle between the lines of pull is not very much. It's almost as if that gravity is pulling that board down. Right, gravity confirmed. If it wasn't already by the fact that you're not floating away from the floor upon which you are stood, Del, and your camera's not floating around, and the chairs and things aren't floating around, and Neil seems to be subject to the same force, because he seems to be pretty well fixed to the floor as well, Del. Can you explain that for us, please, son? That'd be great. What are you showing us here, Del? Have you planned this out at all? Do you have a script? Do you have any kind of idea where you're going? What is this?
As I say, this is just,
No, we don't know, Del. That's why we were relying on you to inform us as to how it is that we've become so confused by actual science and stuff, triangles and mathematics and having an IQ that has at least double and in some cases triple figures to it, instead of your single-digit IQ, Del.
Testing to what? Don't know if I need that part right now. You've already heard me saying what I was saying.
Many, many times, and I don't think you've made any points at all, have you, Del? No.
Here. I think there's another wee part of it.
Clearly, Del is not remotely organised for this, is he? Woo.
Snapped on at the end, so let me just find it. And try and utilise that and assert it as some sort of proof to support his, delusional worldview.
Who's delusional, Del?
So we'll have a wee look at some of it and we'll have a wee chat about it. Don't press on it, I just roll it away. Keep going.
Look at that, disappearing from the bottom up as it moves away from us across the line of the horizon. Good. How's this different from what we've already seen a number of times in this video, Del? What point are you making? Because the points that you are making are all absolutely supporting the globe Earth. Clearly, demonstrably, obviously.
As you can see how far it gets before anything would start to be obscured.
Well, half of that is obscured roughly already. The fact that you weren't able to visually detect it, Del, before that is not the point. That slowly happens and then... God.
On a curving surface. Again, if you look at the distance from there to there, when you see it in the side view, you can see that it's well over 10, 15 degrees.
So what?
Possibly even more than that.
So what?
Okay, now if you look at that, if you see even 10 degrees, you're talking about 700 miles.
But we don't see that on the Earth, because on the Earth, Del, little trucks are not thousands of meters tall. No, they aren't.
So stop, come back, keep coming, stop.
Kilometers tall is that truck. Absolutely thousands of meters tall to that scale.
So even at that point, as I say, stay there. You can see the distance that would have been travelled. Nothing would be obscured.
Except some of that is obscured at the very bottom there. If you look closely, zoom in, you'll see it. And that truck is thousands and thousands of meters tall to that scale, which trucks are not on the actual Earth. Are they, Del? No.
There you go. Keep going back, no, go the other way. Next stop. And now we can see, maybe, can't see until I see in the big screen, the distance traveled.
20,000 subs, has Del. 20,000.
Travel before anything would be obscured if we were living on a sphere Earth.
Which we are. And you've shown it time and time again in this little demonstration by itself, haven't you, Del? Yes, you have, son. Good work.
Okay, you can see the distance there, how many degrees that would actually be. And again, they want to talk about scale.
Yes, because it's important, Del. Oh, goodness me.
That would be even more slight. Okay?
Why? The scale is based on what that curvature is, Del. You absolute cunt muffin. You absolute cockhead. Fuck me.
The exponential drop would be even slighter.
In which case, you have a completely different scale. Fuck. The scale is based on the curvature as you have shown it to us here, Del. That's what we're basing the scale on. That's why I'm saying, well, that truck is thousands and thousands of meters tall to that scale if you were to apply that to the curvature of the Earth as we know it to be. Goodness me.
Comparison, if you scaled it properly to us in the scale of the supposed globular Earth concept, which is a fair bit, yet the majority of the observations we're seeing are over a fraction of that distance.
Well, if you'd like to build a scale model with a truck that's thousands and thousands of meters tall, you're going to see that you're going to be able to see some part of that truck for a great deal more distance than you can view something that is a great deal smaller on our actual globe Earth. And as it turns out, we can work out where the line of the horizon is, which means that we can calculate it to be around about 3 miles or 5 kilometers, which means you will be able to see another 6 foot tall individual, any part of that individual, for 3 miles beyond that point, won't you? Or so. Slightly less because the curvature will start to drop away more rapidly, of course.
So, as I said, questions have to be asked. Again, if we look at this,
I don't think they do, Del. Well, the questions that need asking is, how is it that services have not already identified you as needing constant adult supervision? Why are you allowed to live freely without a caseworker that calls on you every single day to make sure that you're safe and that you haven't done harm to yourself or others around you? It's stunning. I know the NHS is under pressure. I know it's stressed, but goodness me, I think you should present, son.
They're always misrepresenting. They're always showing you this. Now, anybody that levels their camera and looks straight out, where the floor appears to rise into the centre of the field of view.
Perspective, Del. Perspective.
Okay? Nobody ever has to set their camera up and tilt it downwards.
If they want to look at the horizon and they want that horizon to be in the middle of their shot and they are 6 feet tall, or the camera is at 6 feet from floor level at that point on the Earth, then yes, they do need to tilt it down by about 0.02 degrees, Del. That's what the math tells us. It's pretty straightforward. Cockwomble.
In order to see the horizon or look down at the ever-increasing slope going away from you.
Same deal. It's exactly the same looking one direction or the other because it is a sphere. The relationships are the same from every point away from where you are stood, Del. It's initially a gradual dropping away, which becomes more and more pronounced the further away from the point at which you are stood. This is pretty easy to understand.
Which you would have to see, which is the geometry of a sphere, a ball, dictates that must be the case. But you always see the misrepresentation here of them being perpendicular to the centre of gravity, the shift.
Why would they not be perpendicular to not the centre of gravity, the line of force of gravity? The centre of gravity has no vector. It is a point in space. Okay, so let's get that right for a start. The person standing vertically, directly vertically, at any point on the Earth will always be stood in a line which is directly towards that point, which is the centre of mass of the Earth. And the level of floor, if the floor is indeed level, will be perpendicular to that line of force. And obviously that moves around 360 degrees, depending on where it is you're stood on the Earth.
You know that rubbish.
Rubbish and bitsies and stuff. Oh, Del, thanks for the laugh, son.
Right, and then look, they're looking down.
Yes, 0.02 degrees if you're 6 feet tall.
Okay. No straight out. Straight out would be up here.
That's right. Which would be 0.02 degrees above where the line of the horizon is, if you're 6 feet tall.
Looking down.
Yes, 0.02 degrees.
Nobody does that.
Yes, they do. If they want to see the horizon, that's what the math tells us. You just can't detect it because that's such a very small angle. We've covered this.
That's not reality.
Yes, it is.
So something's seriously wrong with these.
Yes, something is seriously wrong, Del, with the functioning of your brain, with your mental capacities. You seriously need to present to services, to NHS services. Get yourself some help, son. Get someone to supervise you 24/7. You're not safe by yourself, son. You're a danger to shipping. Let's move on.
People, again, everybody that knows me knows what I talk about in regards to purely visible phenomena.
Oh, goodness.
And how we account for purely visible phenomena. And that has to be accounted for because there's so many variant factors to be accounted for.
So now say a bunch of words that have really no actual impact on the reality of the situation at hand, the context of what you're talking about at hand. Just saying words to try and convince people with IQs even lower than yours, so somewhere below about 8, I'd say, Del, that you really are a smart boy after all. No, Del. You're as thick as pig shit and probably twice as smelly, I'd say.
Not only just the eye, we're talking about conditions out there in the natural world. None of these people ever want to account for any of that.
Goodness me, they do. They say, here is what we would see theoretically were none of these things at play that slightly affect this result. And they specifically acknowledge that all of those factors that do slightly affect the observation are at play, and that's why the observation that we actually observe will be very, very slightly off from what we would actually predict. And then they go forth and say, here you go. Here's how this works. and they go and make the observations, and they match the predictions pretty damn closely. Apart from those other degrees of freedom that do slightly affect that result. It's called science, Del. It's what we do. Okay.
And they keep wanting to assert that between you and an object that, anything up to, 10, 15, 20 miles, there's a mound.
No, they don't say that, Del. That's what you're saying. Nobody sensible is saying that, because that is not what we observe remotely. You absolute ridiculous gobshite.
In front of you.
No, Del.
I'm just writing down something. Hold on.
I'm glad that you took the time before you made this video to get yourself organised, Del. Good work, son.
So again, never mind this pish.
Never mind that pish. Why?
And looking down like this, that's not reality.
Yes, it is. Except for you got the angles vastly wrong there. The concept that two people stood on the Earth separated by a number of degrees will splay like that, that's exactly reality. So if we move this one to the top and we now use that as our vertical, then that person will look down to see the other one. That is reality, Del. And calling it pash and saying it's not reality has no impact on the fact that it is reality. The thing that the rest of us live in over here, Del.
Right. Reality, you're always at this point.
Yes, that's your reference point. Yep. So?
Okay, if you're leveled and you're looking straight out.
Yes, 0.02 degrees above the line of the horizon, if you draw that to scale.
How can that ever rise up like this?
It doesn't, Del.
How can anything...
Unless you're looking at the top of a mountain, perhaps. That can happen.
Up until a point, as I just displayed to you, maybe about here, right? Would anything ever be obscured?
Yes, correct. And that distance can be calculated using actual math, actual trigonometry. We've had this knowledge as a species for thousands of years, Del, and we can tell you what the distance is. It's, give or take, it's 3 miles or 5 kilometers to the horizon. Good, we're done here.
It's got nothing to do with the surface of the Earth. It's to do with vision, why the floor appears to rise up.
That's to do with perspective. That's why it appears to do that. I've covered this already in a video about crepuscular rays. Go and have a look at that, Del. It's pretty straightforward. Perspective is a real thing too.
Why things appear to get blocked after a certain point. Absolutely not.
Things don't appear to get blocked after a certain point, Del. They get blocked after a certain point. It's not an appearance. It's a known artifact. It's an absolute physical fact. The curvature of the Earth blocks our view of the surface of the Earth beyond a certain range from our vision, which is dependent entirely upon our height above the level of the surface of the Earth where we are stood, assuming that there are no obstructions in our field of view at 360 degrees around that.
Nothing to do with the geometry.
It's everything to do with the geometry, you absolute cockwomble.
Of what you're standing on, okay? Because the absurdity it is, right?
Drawing the same stupid thing over and over again and saying the same stupid thing about what you're drawing over and over again does not make it any more correct the second, third, or fourth time you say the same ridiculous, stupid gobshite. Does it, Del? No.
That you're standing at the top and you've got an observer here or whatever, and you want
Why are they leaning backwards?
to look straight up.
You're not looking straight up.
This floor would have to mound up like that in front of you and then come.
No, Del. No, not at all. Nobody is suggesting that's what occurs, unless you're stood at the foot of a hill, in which case that is what you'll see. And you'll see that your range of vision is vastly reduced by that, because actually what you can see, the limit of your vision is determined by the surface of that hill. That's where your limit of vision is at that point. If you look the other direction where there's no hill, you'll see 3 miles again. This is pretty straightforward, isn't it, boys and girls?
I'm back doing like this. But that's not what happens in reality.
That's right, that's not what happens in reality if there's no hill there, and nobody's saying that it does.
You turn around, you have to have another mount here in front of you.
No, nobody's saying that that's what is occurring either. Cockspanner.
This is what they're trying to assert.
No, they're not. You ass flute. They're not saying anything like that. You're saying that.
It is totally and utterly ridiculous.
That's right, it is, Del, and so are you, because you're the one that's saying that. Nobody else is saying that. That's you saying that.
As I've just demonstrated to you, and I've said it many times before.
We know, and it was wrong every single time, wasn't it? And it's still going to be wrong when you say it again.
Think about the scale of the circumference of even a circle, a ball, whatever.
Yep.
24,000 miles. And you think that over a short distance of 20, even 30 miles, that you're going to have something obscured?
No, I think that occurs over 3 miles or 5 kilometres, because the mathematics tell me that that is so.
Are blocked by supposed Earth curve?
Yes, 3 miles.
Absolutely preposterous.
Yes, it is absolutely preposterous that you don't understand that, Del. You should have learned that at about 12 years of age in school. Trigonometry. It's simple. Triangles, arcs, curves and spheres. It's all covered when you're about 12 years of age, Del, in school. You know, that place that you don't just go there to eat your dinner. You go there to learn stuff, Del.
Total and utter rubbish.
Yes, Del, everything you've said is total and utter rubbish for this entire video. It's ridiculous. Again, 20,000 people are subscribed to Del's channel. Wow.
And again, sun's going down over the curve. So you elevate up, you don't look down at the sun.
You do if it's at the level of the horizon, because the level of the horizon is 0.02 degrees below the absolute line of horizontal as defined by where you are stood on the earth. Yes, you do.
Nobody ever looks down on the sun.
Yes, they do, as described by the mathematics that proves that that is absolutely the case, Del.
Because if they're going to assert to you, and we've got a side-on view here.
Oh, draw some more shit and say some more ridiculous, completely unsupportable nonsense. That'll strengthen your case a great deal, Del, I'm sure.
We'll show it from the point of the observer. They're going to assert.
Everything you've drawn already was already from side-on, wasn't it? So this is going to be a completely different picture of a curve that he gets completely wrong again, is it? Okay, well, let's see.
To you.
Oh, yep, good.
That the sun's doing like this.
Yep.
Right? What's your thought is you should be elevating up and looking down at that fucker?
Why? The thing that's 0.02 degrees below horizontal is the surface of the Earth. Every part of that sun that is above that line is closer to horizontal, and indeed some of that is probably above horizontal because there's quite a bit of it still showing. However, that has no impact on the reality or the mathematics of the situation at hand whatsoever. None at all. That's a pretty little picture on a whiteboard.
Nobody looks down at the sun, is it?
Yeah, they do.
Are they really going to come forward and say they're looking down at the sun?
Yes.
Do you see it from a side-on view? Standing
Same thing again, is it? You're going to draw something completely different now.
here, and they want to tell you that the sun's down there like this.
Because it is, when that's what we're seeing. In that particular diagram there, if you drew a straight line across to the point of the horizon, probably around about half of that sun is above the horizon and half of it's below, so you'd see half the sun. It's almost as if the globe Earth is a real thing, Del. Goodness.
Elevate up, look down at the sun.
Yes, and that's what we see, as per what I was talking about earlier with the people on an aeroplane above the point at which you're stood at that instant would see more of the sun than the people standing on the surface of the earth, because they do. And that's been demonstrated time and time again. You absolute arse biscuit.
That's not reality.
Yes, it is. Saying it's not reality doesn't make it any less real. It's still reality, it's still real, it's still valid, and it's still correct to assert exactly what you're saying is not true. It is true, Del. You haven't shown it to be untrue. You've diagrammatically shown, conceptually, exactly what we do in fact observe. And you're putting that forward as proof that it doesn't, without explaining to us why that's so at all, using any mathematics, any science, any trigonometry, or any common fucking sense. This is crazy.
So, serious questions to be asked, and these people need to...
Yeah, serious questions to be asked about why it is that you are not already under services with a caseworker.
Start this.
You need constant adult supervision, Del.
Plain some honesty, because nothing should be obscured.
Yes, it should, after about 3 miles or 5 kilometres, as per the mathematics. Prove those wrong, Del, and we'll have something to talk about. You haven't done that, have you? You've drawn some pictures on a whiteboard, again and again, showing the same stupid thing again and again, proving absolutely how wrong you are again and again, and putting that forward as if it was proof that you're right and everybody else is wrong. And you've also shown us a board clamped to a table which mysteriously curves away down from that table under some mysterious force that you will claim does not exist, Del, even though you've shown us right there that it does. And then you've shown us little toy trucks that are thousands and thousands of meters tall, as per the scale that you're talking about, and telling us that that's proof that we can see hundreds of miles. Don't worry about the scale, though, says Del, because that's not the point here, when it fucking is the point. It's exactly the fucking point, you absolute cock monkey. Jesus.
For hundreds of miles.
No, 3 miles. 3 miles or 5 kilometres, Del. At an angle of 0.02 degrees down to the horizon. Goodness.
Even with the 8 inches per mile squared, it's missing the point of how it would actually appear. We're asking the questions of how it would appear because we don't live on a sphere.
Yeah, we do.
How would it actually appear if you lived on a sphere?
Exactly as it does appear, of course, Cockwomble. That's how it would appear if we lived on a sphere, because we do, demonstrably.
The dimensions of what they offer you. As I say, they want to talk about scale.
Yeah, we do want to talk about scale, you cock, because it's relevant. It absolutely defines the validity or otherwise of the model that you're trying to propose.
Sheer mass of that would show you that there is absolutely no way for anything to be obscured by a hump in front of you.
That's not what we're saying is occurring. That's you saying that, and it's still wrong for the about 20th time in this video. Nobody is suggesting there's a hump in front of you. No.
For hundreds and hundreds of miles.
No, 3 miles or 5 kilometres. Again, get your numbers right. It's 3 miles to the horizon.
And again, you have to ask the question, the geometry of a sphere is fixed. It
yes.
Drops exponentially.
No.
From your feet in every direction.
Yes.
So why, when you level your viewing apparatus, whether it be your eyes or a camera, looking straight ahead?
You're not. You're looking down at 0.02 degrees to look at the horizon, cockflute.
Does the floor appear to rise and come to just beneath the centre point?
Perspective.
Of the field of vision?
Perspective.
Again, just highlighting the point that there's 2 different geometries that have to be factored here. There's the world that we move around in 3 dimensions.
Yes.
And then there's the world that we view it through.
Perspective.
Through our optical devices.
Perspective, yes. That's all been accounted for, Del. That's what the scientists have been doing all these years. We've got this sorted out. We know how this works. We understand it. You don't, clearly, because you haven't done 12-year-old mathematics.
Because in reality, the flow's not rising up like that.
No, it's not. Correct.
Things are not getting smaller.
No, they're not. They appear to be getting smaller because of perspective.
With distance. The sky's not coming down. Things...
Correct. The sky's not coming down. Goodness. The sky's not a solid thing, Dale. It doesn't have a surface.
They're not converging to a point.
No, they're not. It's perspective. We understand perspective. You don't, clearly.
That's not reality.
No, that's perspective. And nobody's saying that is reality. They're saying that's perspective that causes that illusion.
That only happens here.
Yes.
Of course it would, Keith Anthony, that's the whole point. Well, Chris says that's exactly it. Because when we're dealing with visible phenomena, we're looking at vision.
Yes.
We're not looking at the three-dimensional world. Okay, that's not quantifying the three-dimensional world, it's only the vision.
Yes.
But again, it's just about the dishonesty of these people that come.
No, it's about your stupidity, Del. It's about your inability to understand basic concepts, which hold true and have nothing to do with perspective.
Call themselves scientists or investigators.
That's because that's what they are, Del. What are you? Other than someone who desperately needs to present to services for constant adult supervision. I hear children in the background. I really hope you're not a primary caregiver for a young person, Del. That would be worrying in the extreme.
But they're so disingenuous that they just...
No, they're not, Del, at all. No.
Just keep a certain nonsensical drivel.
Nonsensical drivel, says Del. Okay. I think we've seen clearly who it is that has the nonsensical drivel going on here.
It's totally contradictory.
No, it isn't, Del. There is nothing contradictory in what has been presented by the actual scientists who do understand both geometry and perspective, who have got this nailed down, absolutely, and whose predictions are met by observation to a incredible degree of precision, time and time again. Completely unlike yours.
To the asserted model that they propose, right? Just as I've displayed, and anybody can display.
You haven't displayed a damn thing today, Del, have you? No. You've shown a piece of board curving under the force of gravity. Well done for proving gravity exists, absolutely. You've shown some ideas time and time and time again, which are completely invalid because of the complete lack of the application of any form of accurate scale to the phenomena to which you are extrapolating. And you've said a bunch of ridiculous cockflutery again and again and again, as if saying the same stupid thing again and again makes it less stupid. No, Della, it makes it even more stupid.
Play that for themselves. So see, I was being generous with the curve on the apparatus that I set up.
No, you were being completely invalid with your scale, which invalidated your argument entirely. The only thing you showed was that the argument, as it is presented by those people who actually understand this phenomena, is absolutely borne out by your observation. Goodness me.
If I was to increase the scale of that even more,
yeah,
you would see exactly how far it would get before.
Yes, 3 miles. To the line of the horizon, from a 6-foot high position above the surface of the earth at that point. Yes, you'd see exactly that. And that's what we do see. Exactly.
Before anything would become obscured. And I'm saying you're literally talking hundreds and hundreds of miles.
Yeah, absolutely. You'd be able to see a truck that's thousands and thousands and thousands of meters tall, or some part of that truck, for a long, long distance. Yes. But bring the truck down to the correct scale for the curvature of the earth that you've shown, and you won't. Goodness me, that's not difficult to understand, even if you do have an IQ less than about 8.
So, you can't have things rising up and humping up.
Nobody's saying we do. We've covered this one about 20 times in this video already. You're making shit up, Del.
During you. That's not conducive to the geometry of a sphere.
Correct, because We are living on a sphere, and we don't see things humping up in front of you. We don't all stand in a dimple at all times looking up at humps all around us. No.
Maybe a golf ball Earth or something.
No, we're not living on a golf ball Earth. No.
You know, but it's got dimples everywhere.
No, Del.
And everywhere you go, you're inside a dimple.
No. No, not at all.
Then maybe you could have this.
Yeah, maybe then you could have that, but we don't have that, and we don't see that. So your point falls absolutely, for want of a better term, flat.
Humpage in front of you.
I think I'm looking at a humpage in front of me. I really do.
They really want to pull their socks up and stop being so dishonest and stuff.
Yes. I think we know who it is that needs to pull their socks up, Del.
Addressing these things properly.
I believe I have done in this video quite clearly. If you have more than about 2 brain cells, which clearly Del does not.
That's what I'm saying, you know.
Yeah, we do know, Del. We understand what you're saying. You don't understand what you're saying. That's the problem here. You're saying words. And 20,000 people have subscribed to you and want to listen to you saying words. It's worrying. Worrying.
Any direction we're downhill exactly, Suddy.
That's right. Well, every direction is down with respect to the line of horizontal at the point at which you are stood. Hill refers to a deviation away from sphericity. A hill is a deviation in the sphericity. A valley is a deviation in the sphericity. Everything is not downhill from you. Did you see that thing where that guy was talking at a conference and he said if you were driving from Edinburgh to London, you wouldn't need any petrol because it's downhill all the way. Ugh. The line of gravity changes as you move, doesn't it? The line of gravity pulls you straight down towards the center of the Earth, around 360 degrees of the globe in every direction. Del.
That's it, YouTube. But they're so up their own arse that they're not admit they're wrong. And people don't let them. People let them away with it because they keep asserting these things like curve calculators, showing skewed misrepresentations and asserting humps in front of you.
No humps in front of you, Del. No.
This crap. Just stop and ask yourself the question: how would it actually appear?
So how about stop and ask yourself the question: how is it, Del, that you have got this so utterly screwed up? How have you got this so fucking wrong? How is it possible that you are so monumentally fucking stupid as you are? Are your parents cousins? Or maybe they're brother and sister or something, Del? Goodness me.
If I lived on a sphere Earth.
You do live on a sphere Earth.
Not just assuming that it is a sphere Earth and then asserting what you would see.
That's not an assumption. It's an absolutely tried and tested fact. You live on a spheroid Earth. It's very close to being a sphere. There is no question of that, except in the minds of you flat-tarded fuckwits who can't grasp basic concepts like gravity, geometry, trigonometry, mathematics, those kind of things that you should have learned as a 12-year-old schoolboy.
See, because that's not how it works. That's right, Tony Dixon. Exactly. Parallel lines only appear to converge due to vision.
That's right. Perspective. We've covered it.
Non-reality.
It doesn't have any effect whatsoever on what we are talking about here. It's a phenomenon that we know about. We can therefore correct for that to understand why it is that we see what we do in fact see. And then we can check with that correction, should we be correct about our underlying assertions here about the geometry, trigonometry, and mathematics in the real world, do we see what we would predict that we should see? The answer is yes, Del, we do. We see exactly what we would expect to see. That's how science works. That's how we have completely and utterly verified and ratified the ideas that we live absolutely on a globe Earth. And you've shown it yourself today. Time and time and time again, without little fucking hindrance, and then presented exactly your proof that we do live on a globe Earth as being the exact opposite, as being proof that we don't. Because you are a cockflute of the highest order. You are an arse monkey.
Masonic girl, aye. Because on a globe you're always at the highest point, that's it.
Yes, on a globe, you always perceive yourself to be at the highest point.
Exactly, have no sphere. That's absolutely absurd, Jacob, isn't it?
I presume Jacob just suggested that Del has an IQ over about 8. Of course, the only possible response Del could have had to that was, yep, it's absurd, because Del's IQ is probably around about 7.
I'm a Freemasonic plant, whatever, son. Whatever. You can't.
Yeah, okay. I think we're done here. I think Del is just now reading love letters from his similarly flat-tarded supporters, numbering 20,000. Goodness me. Well, boys and girls, I hope you enjoyed that. I hope you found that as amusing as I did. Goodness me. That was episode 1 of folks that have more subscribers than I do. I hope this has raised your expectations for the world. I hope that you are now happy about the future of humanity. I hope that it has laid or put any fears you might have had to rest, that we are in good hands moving forward, and the next generation of Glaswegians coming at least out of the auspices of Del's place. Things are looking good, aren't they, boys and girls? Wow. Anyway, in summary, no, Del, wrong about absolutely everything you've said in your video, of course, demonstrably so, obviously so, patently so. Please do go and present yourself to services, get yourself some help. Her Majesty's NHS stands ready, I'm sure. I know they're under stress, but you need some help, son, because you really should not be making decisions on your own. Okay, for the rest of you, join me next week when people will still be wrong about things on the internet. See you then.